Software Engineering Radio, episode 107, Andrew Watson on the Object Management Group.
This is Software Engineering Radio, the podcast for professional developers, on the web at se-radio.net. SE Radio brings you relevant and detailed discussions and interviews on software engineering topics every 10 days. Thanks to our audience and the partners listed on our website for supporting the podcast.
Welcome, listeners, to another episode of Software Engineering Radio. This is another episode we're recording at OOP 2008, and we're, of course, thankful to the OOP organizers for giving us the little room which we can use here. In this episode, we are going to talk about the OMG, what it does, why it exists, and all that. We are talking to Andrew Watson. Why don't you introduce yourself to our listeners? You can do that better than I can.
Thanks, Marcus. Well, my name's Andrew Watson. I'm Vice President and Technical Director of OMG, Object Management Group, which is one of these organizations whose mission has changed a little bit over the years. So now we tend to call ourselves OMG rather than Object Management Group. I guess if we were renaming ourselves today, we might call ourselves something like the Interoperability Management Group or something like this, because interoperability and standards for interoperability has become our key focus in the last few years.
Yeah. Right, it's like SOAP. The meaning of the acronym has been deprecated.
Yes. Well, and has changed and so on, yeah. It's OMG was set up in the late 80s when the enthusiasm about objects was starting to build. Objects were a technology that had been in the laboratory, places like AT&T Bell Labs and Xerox PARC, and was starting to move into industry. And there was a determination amongst many engineers that this history wasn't going to repeat itself. They had just been burnt by the Unix wars. Unix was a technology that promised to free the customer from lock-in to proprietary operating systems. And of course, as soon as Unix got out into the marketplace, it fragmented. And that phase is past now. Of course, we have Linux and System 5 and standardized APIs. But for a while, it looked as though Unix was going to be fragmented and diluted. When object technology started to get out into the marketplace, there was a group of determined engineers who worked for a number of software companies in the northeast of the United States who wanted to make sure that there were standards, public, open standards for object technology to avoid the same thing happening. And OMG is still very strongly involved in object technology, of course, but we no longer are completely limited to just working with objects.
I guess that's the same fate, if you want to call it like that. Like, for example, the conference we're at here, it's called OOP, which stands for Object-Oriented Programming. Well, or OOPSLA, right? So these have all gone broader. And
objects have become mainstream, completely accepted. As with all of these, quote, revolutions, it seems to take a generation. It seems to take 10, 15 years for a good idea that's emerging from the labs to become mainstream and completely accepted. And of course, we're looking at the same thing today with things like SOA. SOA is a technology that has got a lot of press in the last 2 or 3 years. But in fact, when you dig down, you'll find it's a very old idea. Arguably, arguably. I mean, I worked on a research project in Cambridge, where I live in the UK, in the early 90s, and arguably we were doing. I would definitely argue we were doing service-oriented architecture then. That was the ANSWER project, and in turn, we were building on even earlier technology. When I give my talks, I mention SOA technology going back to the late 70s. But the important point is not, we thought of it first or somebody else thought of it first. The important thing is that SOA is a good idea, which is now entering the mainstream after a long period of being carefully investigated and researched. And the same is true of objects and many other technologies.
And all of them are obviously evolutions or evolutionary developments on stuff that has been there before. And at some point, I guess the community decides to give something a new name. Maybe either because it has changed enough, so it should have a new name, or just, I don't know, for being able to maybe put it, to hype it a bit.
Maybe, but I take a slightly more positive view. It just does take time for good ideas to spread. We all get a little set in our ways. We all carry on doing what we understand, what we know. It just does take time for good ideas, for it to become recognized, their value to become recognized, and for them to spread. The corollary is that happily, bad ideas tend to die.
Yeah. Okay, let's briefly go back to the beginnings of OMG. So you said that the goal was to make sure that the OO, the object technology, doesn't fragment. So what was some of the first results of what OMG did? What was one of the first standards that people probably can relate to?
Well, the first standard, of course, that I'm sure a lot of people are aware of is a thing called Corba. And Corba is an object-based middleware specification. It's a standard for interoperability, both between applications and the middleware, and between separate instances of the middleware that are running on separate platforms. Yeah. So that you should be able to go out and buy Corba implementations from multiple vendors, write applications against the standard Corba APIs so that you know that your applications will be portable between vendors. And also, if you buy from multiple vendors, put vendor A's implementation on one machine, vendor B's implementation on another, have them talk together. Corba has been used in the past very widely in the enterprise. It still underlies enterprise Java Beans, EJB. So a lot of people who are using EJB are using Corba technology today without realizing it. And it's used very widely today in real-time and embedded applications.
Yeah, that's actually a focus I've seen, that the enterprise moves to the more WS star stuff, and Corba goes to the more technical embedded real-time environment.
And it's being used in some quite interesting and surprising places. Moore's law tells us that the amount of CPU power and the amount of memory doubles every 18 months. So something which 15 years ago was an enterprise, and let's not forget, Corba is 15 years old now. Something which 15 years ago was an enterprise scale system that you needed a huge air-conditioned machine room to hold, today literally fits in the palm of your hand.
Yes.
So one of the applications where Corba is being used today is in software-defined radios. The US military found itself with, I think, over 100 separate radios that were being used in different branches of the Navy, the Marines, the Air Force, and so on. And it was getting to the point where if one vehicle needed to interact with aircraft and ground vehicles and soldiers, it needed to carry several radio sets, and it was getting to be literally a problem fitting them all into the vehicle, particularly an aircraft. So they took a very brave decision a couple of years ago to put a bar on buying hardware radios, standard radios, where the performance of the radio is determined purely by hardware, and to switch to software-defined radios, where software running either on general-purpose processors or on exotic DSPs and FPGAs, but anyway, software that can be loaded in the field defines the behavior of the radio. So one radio can not only have its personality change very quickly by loading a new, what the software radio people call waveform. It's a shorthand for all the software that drives the radio. Loading a new waveform into a radio can change its personality very quickly, but also one radio can have multiple waveforms loaded at once. And so that you can get to a situation where one device can load several of 100 different waveforms and talk simultaneously to satellites, aircraft, and ground vehicles. Now, the US military are spending a startling sum of money on this. I can't remember the numbers off the top of my head, but it is measured in billions of dollars. And inside every single one of those software-defined radios that they're acquiring is Corba. They've built the interoperability standards for the multiple processors within the radio, the 5 or 6 processors inside the handset or the vehicle radio, all talk to each other using Corba-based interfaces. So Corba is one of these technologies. We've always said that middleware is like plumbing.
It's good if you don't see it.
Yes, exactly. You don't remember that you've got plumbing until you come downstairs one morning and find the kitchen is knee-deep in water, and then you remember, oh yeah, I have plumbing, and guess what? It stopped working. So similarly, middleware is one of these things where you don't really notice it until it stops working, and this is a great illustration of that. It'll be inside all of those software-defined radios, and nobody who's using them will have any idea.
Another standard.
Well, let me continue the story chronologically. Yes,
exactly.
in the late 80s, we worked on Corba and related specifications, standardized some services. Essentially, Corba was the foundation of a service-oriented architecture. OMG has 15 years of experience with this. And then in the mid-90s, we acted as a forum for brokering agreement in the object-oriented analysis and design world. If you were paying attention to what was going on there in the mid-90s, and I have to admit I wasn't, but if you...
I was too young.
Yeah, well, I'm sure you know, yes. Young, fresh-faced chap that you are. There were probably about half a dozen different visual design notations that had been designed through the early 90s by different authors who were keen to have a way of visually representing designs for object software. Object software was new. We needed new notations for representing these designs. And many of these notations were very good, but of course they were all different. They'd been designed in isolation. And the net result was there was little uptake. Customers were confused. They didn't know which one to use.
Yep.
They were reluctant to invest heavily in using any one of them for fear that their investment would be lost if that notation stopped being used, stopped being supported. Ivar Jakobsen, who was at Ericsson at this time, estimated, he came up with a figure of, I think, a couple of $1 million a year that Ericsson could be spending on documenting their designs using an object-oriented design notation. And of course, if they pick the wrong one, that's several $1 million worth of investment that becomes so much scrap paper if you can no longer find people who understand the diagrams or buy tools that implement them. So customers were confused. There was not much of a market in the tooling. Again, because there weren't that many customers, too fragmented. Yeah. The whole market was balkanized. And a couple of things happened in the mid-90s, which we helped broker. First of all, of course, three of the leading exponents of object-based design came together as a single company, Rational, the so-called three amigos, Jakobsen, Booch, and Rumbaugh. And secondly, OMG put out what we call an RFP, or request for proposals, one of our documents that starts a standardization process for visual modeling. And between these two influences, between the initial grouping at Rational and this the activity that OMG started, through the mid-90s, we achieved standardization of what today we know as UML. UML has changed a little bit over the years. There were early versions at Rational that were called UML. But the thing that OMG adopted was noticeably different. And incidentally, we did have a bit of a dilemma there. Should we call the OMG specification UML, as the three amigos had generously given us the rights to do, even though it was a little bit different? It was noticeably different to what they had created. Or should we recognize that it was a new development and give it a new name and risk losing all the brand recognition that the UML name had built up? So we, in the end, as you know, we stayed with the UML name, but it is important to recognize the contributions that many other people, 20 organizations, contributed to the UML1 specification. It's not just a rubber stamping of the excellent work that the three amigos did. And the result from about 97 was we had UML1.
Right, yeah.
Now, of course, we have UML2, but even UML1 had a dramatic effect on the market. And obviously, I'm a standards guy. I work for a standards organization. I believe in what I do. And I will, at the drop of a hat, stand up at the pulpit and preach the sermon of standards. And my text is taken from the story of UML. Because before the UML standard came along, the market was fragmented. There basically wasn't a market in visual design tools, and the techniques weren't being used, although they were all good. After the creation of the UML standard, the mere existence of the standard created a unified market, and that market grew at about 20% a year through the turn of the millennium, through about 1999 to 2002, even as the wider IT market went into recession, went into decline. So, and I'll just finish my point here. The important point is not that UML is necessarily technically better than what went before it. We can have that argument, and there are people here at this conference who would argue, tell you all about UML's flaws. And I'm happy to admit that UML, like any standard, certainly there are always things that could be improved. It's not that it's necessarily better. It's the fact of a single standard that creates marketplaces. Standardization does not destroy competition. It does not destroy innovation. On the contrary, it acts as a springboard for healthy competition and innovation in a market like this. It's been UML is a very, very encouraging story for us.
I guess many of the criticism, and I'm also often criticizing UML for certain things, the criticism isn't necessarily that it's a bad language. The criticism is more that it's, quote, misused. So, I mean, UML was built for certain things. and it was not built for certain other things, and for certain other things there might be better solutions. I mean, for example, if you look at the meta case folks, for example, who like to bash UML and they 10 times better than UML. I guess for what they're doing, they really are better than the UML. So I think one of the dangers of standards, and I experience it every day if I work with my customers and talk about domain-specific languages as opposed to UML, is that as soon as there is a standard, people use it for things for which it wasn't initially thought to be used and for which it maybe isn't necessarily suitable. XML is the same thing. So I think that's a big argument. What should you use it for and what you should maybe not use it for?
And again, it comes down to something we mentioned earlier. You know, if you're good at one technology, if you understand one technology, you do tend to apply it to a lot of things,
Right.
and maybe sometimes the things that it's not applicable to.
Yeah.
The old expression, you know, if you have a hammer,
Right.
everything looks like a nail.
Yeah.
But nevertheless, UML has been designed to be flexible. You mentioned domain-specific languages. OMG has, separately from UML, standards to help us build domain-specific languages,
Yeah.
the modeling framework that UML is built on, I think.
Is it now called modeling framework MOF, or is it does it still mean meta object facility?
MOF actually stands for meta object facility.
Okay, I thought
so
it
that
modeling
name hasn't
framework.
changed. But,
Okay.
but I refer to it as a modeling framework
Right.
because that's what it is. It's a framework, or
Yeah.
it can be used as a framework
Yes.
for building modeling languages.
Yes.
And OMG has built several other modeling languages
Yeah.
using this same modeling framework.
Right.
We have a couple that I'd like to mention later on in this podcast. BPMN, the business process modeling notation, is being moved on to a MOF platform.
Mhm.
SBVR is a completely un-UML-like language for expressing the semantics of business vocabulary and rules,
Mhm.
and is attracting a lot of interest in the business community as a way of formally documenting simple things like the meanings of words.
Mhm.
It sounds very straightforward, but one of the major sources of confusion I have found in my work on standards and specification over the years is just disagreement on what the words mean.
Yes.
And I'm sure you've had the same experience.
Yeah.
You have those interminable arguments that last for days, where
Yeah.
nobody seems to. The other guy just seems to be spouting gibberish.
Yeah.
Well, no, actually, he's using all the right words, but what he's saying doesn't make sense. And
Yeah.
then you realize after a couple of days, oh, your definition of this term, wombat,
Yeah.
is subtly different to my definition of wombat, and
Yeah.
therefore all the other misunderstandings flow from
Yeah.
that.
Yeah.
SBVR is a specification which will help businesses come up with precise definitions of, if you're a car rental company, exactly what a rental agreement is, exactly what a customer is.
Sounds a bit like ontologies.
Yes. And another specification that SBVR is related to that OMG is working on is an ontology definition metamodel,
Okay.
which will then help us to relate work done in SBVR with
Yeah.
work done in OWL, RDF,
Yeah.
and common logics and so on.
And the ODMM is also based on MOF, I guess.
The object definition metamodel, yes. We actually call it ODM. We're sometimes a little inconsistent. You're right. Sometimes MM is metamodel, and
Yeah.
sometimes we just use
Yeah.
the M ones. But yes, ODM is also based on MOF. This is one of OMG's great, although slightly hidden strengths right now.
Yeah.
We're doing a lot of work on creating a lot of modeling related specifications, but it's all based on the common MOF framework, which is, of course, then strongly related to what Eclipse is doing with EMF. So
Right.
there are open source implementations.
Yeah. I mean, that's one of those things, right? There is MOF, CMOF, EMOF, EMF, and none of them is exactly the same. But
yes, we do. I'm happy to say, well, not happy to say, I'm happy to admit that we do have an issue there. But again, it's one we're moving to address. We're organizing in March at EclipseCon.
Yep.
We have a full day symposium on alignment between OMG specifications and Eclipse open source software. And anybody who's interested in that, do please come along and participate. It's going to be an open forum. We want to work out how we can bring OMG specifications and Eclipse open source software more closely into alignment. We're also going to run a version of the same symposium part 2 of the same symposium at the OMG meeting in Ottawa in June. An open invitation. If anyone who's interested in making things better in this area, please come along.
Okay, we should maybe make sure that we put this podcast online before those days.
Okay, yes. Sorry about that. I didn't mean to force your hand there.
Oh, you can always cut it out. So I think from my perspective, MOF is much more useful than UML because a meta standard that helps you to define languages and that therefore makes tools for language definition interoperable is, in my view, much more useful than, let's say, implying a standardized modeling language. But that's just my background. So I'm obviously not saying that's necessarily true, but I have much more interest in MOF than in UML because for the model-driven work, it's more important, obviously.
Yeah, but to come back on that, it does lead into an interesting point. People get attached to syntax.
That's true.
I have this theory that every programming language that's created for the next few years
is
cursed. Exactly. You have the point. Is cursed to have syntax that's slightly reminiscent of C++.
I agree.
Because that means that you can hand the language over to somebody new, and they'll be able to write the Hello World program and get it to run within half an hour or an hour. And once you can do that, you've got them. The fact that the underlying semantics may be completely different might take them weeks to learn.
Yeah.
For instance, Java and C++ underlying model is very different, but you can take a C++ programmer, give him the Java book, he can have Hello World running inside an hour, and you've got him.
Yeah.
Emotionally, you've got him. If you give him a wonderful new language with a completely new syntax that takes weeks to learn, he's probably not going to get over that learning curve. Now, my point that I'm coming to is UML has had the same influence.
I agree. Yeah.
Not everybody uses UML, but people who invent new domain-specific languages, which is, I certainly no criticism of that, but what they often do, quite reasonably, is create them with UML-like syntax, and they explain them as, well, this is a lot like UML's class diagram, except it's different in these ways.
Yeah.
So UML's influence is destined to be a lot wider than just the people who use UML per se. I think a lot of people are going to be using notation that is reminiscent of UML for a lot of different jobs when they create their domain-specific languages. And incidentally, OMG has provided in UML a simple mechanism for building domain-specific languages that are closely allied to UML, the so-called profile mechanism.
Yeah.
It's been used. I can see there's a little bit of skepticism across the table here, but look at SysML.
Yeah.
SysML is proving very successful. Yeah. It's strongly based on UML, and it's entirely defined using UML's profile mechanism.
No, I mean we shouldn't stretch this argument forever, and obviously UML has a huge impact on people to sketch, discuss, talk about systems. Yep. Clearly, no question. And also, it's good to have a standard, especially in systems engineering, where you have 5 million vendors and like supply chains, and everybody needs to agree on something. That's completely given, no question. The profile mechanism, I know that it can do everything in theory. Tool support for it is limited, so the things you can actually do is limited. And then there is another, I think, problem with it, and that is that if you have a profiled UML model, even if you have your own domain-specific profile, what you get out of your tool, XMI export or something, is still extremely complex because you cannot take anything away from the UML, at least not on the, let's say, AST level. So there are limitations, and so
of course.
Yeah.
And it's important to say I'm certainly not claiming that UML is the answer to every problem. Some people do like to set up. I mean, it looks good in magazine articles, that somehow there's this battle. This battle royal between, on the one hand, the UML zealots, and on the other hand, the domain-specific language enthusiasts. It's not like that. There's a spectrum.
Yes, I agree.
And on one end of the spectrum are people who, for perfectly legitimate business reasons, want to use a completely standardized language and will restrict themselves to just using completely standard UML. Yeah. And then we move through the people who will customize UML a bit using profiles, all the way to the people who want, again, for perfectly legitimate business reasons, to create an entirely new domain-specific language for their particular domain. Yeah. I don't want to sound smug, but the great thing about OMG's modeling offerings at the moment is we can support everybody on that spectrum. I say we, and the OMG community, the community of organizations that uses OMG specification.
Or maybe through UML.
Yes, at one end of the spectrum, we have the UML specification. At the other end, if you want to go out and build a complete new domain-specific language, MOF provides you with tooling to do that.
Yeah. Okay, since we're already talking about some of that modeling stuff, why don't you mention the MDA standard? I guess everybody knows what it's all about. But why don't we discuss the current status, the sub-standards that are applicable, and what their status is?
Sure. Well, MDA, model-driven architecture, it's really more of an initiative than a standard.
Right.
It's a family of standards.
That's a good point.
It's, as you said, a lot of people use modeling notations for sketching, for communication. That's fine. But we can, if we use modeling notations precisely, we can extract quite a lot of information about system design from them and use it, at the very least, to build the framework of an implementation.
Yeah.
I'm very careful not to over-promise on MDA. So some people
I think that happened initially a little bit, at least between the lines.
It didn't come from OMG.
No, that's not what I'm saying. But between the lines, there were a lot of I think about something and press the MDA button, and then.
But that didn't come from OMG.
No, I'm not saying that.
We were very careful right from the beginning to make sure that we weren't promising IT nirvana, where you go out, draw a couple of diagrams that represent the system, press a button, and a working system pops out of the Mac. But even with quite crude modeling notations, and UML1 wasn't designed for MDA and had to be adapted a little bit to make it work. UML2, incidentally, is a lot better. One of the design points for UML2 was to clean up the underlying meta models to make it more compatible with MDA. But even with UML1, it was possible to build tools which would spit out function frameworks and database schemas and so on, and that would probably write 30-40% of your code. And the tedious code as well, not the interesting business logic, but all the the tedious interface definitions and database definitions and so on, and the glue code. And incrementally, as the tooling has got better, the percentage of your application that you can get out of MDA tools has increased over the last few years.
Sure.
The impressive thing for me is zooming back and looking at the big picture. There was a study from Walt Disney World that we had a couple of years ago. These guys wrote 2 parts of one of their billing applications using different technologies. So it wasn't a fully controlled study, but it was close. On the one hand, you had a team who were using a good traditional programming environment with Java, of course. And on the other hand, you had a team that was using a suite of MDA tools, not good MDA tools, but not leading edge.
Yeah.
And 2 things. First of all, the people who were using the MDA tool were 3 times more productive. They wrote 3 times more lines of code per dollar spent than the people who were using the non-MDA technique. So you're looking at greater productivity for you guys at the sharp end, the programmers.
Yep.
But for me, more impressive was the bug rate. The bug rates in the code that had been generated, that had been created using MDA technique, were 1/3 those encountered in traditional hand coding. So, of course, in both ways of creating applications, you can still get the design wrong.
Sure,
and if you've got the design wrong, then the implementation will be wrong.
Yeah.
But when you code by hand, there's another step where you can inject errors. You can take a correct design and just make a coding error.
Yep.
MDA doesn't eliminate that, of course, but it reduces the scope for doing that. And we've found this in several studies. And let's not forget that if you're building a successful system, which we all aspire to do, if you're building a successful system, anything up to 90% of the cost of owning it, the total cost of owning it over its entire life, that might be 10, 20 years, 90% of that cost is post-implementation.
Yeah.
It's training the people who use it, and training them is harder if the system's buggy.
Sure.
You do this, you do that, and then you do that, but if this happens, then you have to work around it by doing this.
Yeah.
And you have to train people for 20 years to say, and if that particular error message happens, you have to work around it like this. That bug's not there. It's cheaper to train the people to use it. You don't have to fix the bugs.
Yeah.
That kind of thing. So the biggest impact I feel that model-driven techniques will have on software is not the initial productivity of creating the systems, although that's useful. It's the increasing of the quality of the systems, and therefore the reduced total cost of ownership over their lifetimes. That will dominate all other effects. And to that, I should mention one of the other initiatives that's part of MDA is a thing called architecture-driven modernization, which humorously turns out to be MDA backwards, ADM. The ADM specifications are important because if we're going to be using MDA to create systems, we have to recognize that nobody has a greenfield application.
Right.
everybody who's writing code today, I think it's fair to say without exception, has to interface with other code that's already out there, legacy systems. Isn't it fun? Funny, we refer to legacy systems as though there's some quaint holdover from a previous age.
Well, it's everything that's already out there.
Everything that's already out there, and by golly, there's a lot of it. Estimates are that application engineers across the software industry collectively spend more than 50% of their time maintaining old applications, maintaining legacy applications. Yeah. So it's important to have a way, when we're creating applications using MDA, it's important to have a way of interfacing them with existing applications. ADM standards are about the certainly very difficult job of trying to pull design information out of old applications where no design exists. And nobody, again, it's important to emphasize, nobody's claiming that you throw a heap of code at an ADM tool, press a button, and a perfect UML diagram pops out the front. This is always going to be a process where a skilled engineer has tool assistance rather than the tool doing all the work. But it is vital that we have ways of extracting designs from old code so that model-driven techniques can then help us build new code that interfaces with the old code. So that's a very important part of the MDA story.
And ADM is finalized, or is it in the process?
ADM is actually the name of a group inside OMG that is working on a number of specifications.
Okay.
Their first one is a thing called KDM, which is Knowledge Definition Meta Model. And that's a standard meta model, a standard set of concepts for representing aspects of software design. They've got a lot of work ahead of them in ADM to work on more specifications representing more parts of the reverse engineering process. But we've made a start. And an interesting spin-off from that has been into software assurance. People who do software assurance, who look at off-the-shelf applications and try to work out, say comes back to the military. You've got a drive in the US military for buying more software off the shelf. Great. Costs come down, quality is probably just as good, except you're paid to be a little bit paranoid and you want to make sure that nobody's put any backdoors in this code. How do you do that? Software assurance efforts are there to test existing software to make sure that it works within some specified set of criteria, including security criteria. There are no backdoors, there are no covert channels. And it turns out it's a very similar problem to reverse engineering.
Right, because you have to understand what's going on.
You have to understand what's going on. So there's a group that has spun off inside OMG from the architecture-driven modernization group that's just looking at using similar standards, ADM standards, for software modernization. And the good news from our point of view is because of this drive for using more off-the-shelf software in governments and so on around the world, there's now a lot of government money around to say, well, now we bought this software, help us be assured that it does the right thing. It's an interesting area, interesting spin-off that I personally hadn't really foreseen.
You mentioned a couple of the more specific standards that the ADM folks are working on. So what are some of the more specific standards what MDA comprises, and what's the status of them?
Well, the other things that we're doing as part of the MDA program are several specifications to do with models and MOF. Once you've captured your design using UML or another modeling language, once you've captured design in the MOF framework, MDA, the foundation of MDA is about transforming those models into other forms and then extracting information from them and using it to create whatever it is, database schemas and so on. Well, yes, ultimately everything's a model, but at some point you want to get to a model that's represented as C code, or a database schema. So a couple of useful specifications there, and I'll just touch on these efforts. Don't want to go into too much detail. There's a thing called QVT, which stands for Query, View, and Transforms, which is a suite of specifications under one standard for transforming MOF models into other MOF models. It's important to say, in each of these cases, just because OMG is standardizing something, it's absolutely not the case that this is something that was impossible before. We aim not to innovate with our standards. We aim not to be doing research.
Although there is something, this criticism that OMG standards aren't always pragmatic. But let's touch on that later, I guess.
Well, we can let's just touch, we might as well touch on it now. It's a fine balance to strike. If you've got an emerging area of interest, such as how you transform a model to another model, if you create the standard too early, you're taking research and you're codifying it as a standard, and that's likely to be a disaster.
QVT relational a bit has that smell a little bit. I think
It's we revise our standards, so if we see that there's an issue and people feedback problems, yes, we beat these problems out. We also certainly don't claim that any of our specifications is perfect,
of course.
At a sort of a diversion from a diversion, I should mention here that if anybody comes across a problem with one of our specifications, please do get in touch with us and report it. We have a bug reporting process. We have people whose job, so-called revision task forces, whose job is to maintain these specifications. We don't claim they're perfect. If you found a problem, we want to hear about it so we can fix it. But coming back to where was I? Coming back to the stack. Unpop the stack, yes.
So I think we were talking about QVT.
Yes, we're talking about QVT. And so QVT is a set of specifications for how you transform models into other models. Something that certainly MDA tools have been doing for some years. Now seems like the right time to standardize this so that if you've created a set of transforms in vendor A's tool, you have a chance of being able to port them to vendor B's tool.
Which is currently, with most mainstream tools, not yet the case. So
exactly.
I think,
yes. Yeah. And implementations of QVT are really just starting now. It's
most of them are operational.
Yeah. As with all these things, when OMG publishes the specification, it can then take a couple of years for it to get into a large number of tools. There will typically be a couple of implementations around a publication time. But it'll take a couple of years to get into a large number of tools. So QVT is one important MDA-related specification. MOF model to text is another one. That's a specification for standardized ways of taking MOF models and turning them into arbitrary text like C programs, database schemas, and so on. And there are several other initiatives around MOF. The standardizing the workings under the bonnet, as we Brits would say, or under the hood, as the Americans would say, under the bonnet of MDA. Other work that we're doing is in the area of other modeling languages. I've mentioned a couple of them. SBVR, BPMN is an interesting one. BPMN is business process modeling notation. Unlike UML is a family of 13 or so, depending on exactly how you count, but somewhere around 13 different notations. BPMN is a single notation for drawing business processes, and it's specifically been designed to be usable by and friendly to the business user. Some business users are a bit intimidated by UML. There just seems to be a lot there. Too big, lot there. BPMN has been designed so that a business analyst can sit down maybe with a programmer or maybe even an end user, somebody who actually madge from accounts, who actually works through the process of filing accounts, can sit down and say, okay, when I file an account, I do this, this, and this, and you can document it in BPMN in a way that's very readable. It's like a flowchart with swim lanes. But at the same time, precise enough that we can extract information from it and use it to inform an MDA process. BPMN was originally designed by a thing called BPMI, Business Process Modeling Initiative, and wasn't initially based on MOF. And so one of the things we're doing at the moment through another BP standard, just as all the standards in web services are called WS something, so all the standards in OMG to do with business processes are called BP something. So another BP standard is BPDM, Business Process Definition Meta Model. And this is brand new within the last couple of months. It's a standard meta model for representing business processes, so that even if you've used other business process representation languages, you can map them all onto a common meta model. So the long-term goal here is that BPMN, or more specifically a second version of BPMN, will map onto BPDM, the business process definition meta model, which in turn is built on MOF, to give us this same path from diagrams to models that we've already got in the UML corner of MDA. So I think one of the strongest areas of growth at the moment in OMG, one of the most exciting areas, is the work on business process standards. Another specification that we're working on at the moment, which is somewhat outside the MDA stream, is BPMM, the Business Process Maturity Model. This is a new departure for OMG because this is not a model in the MOF sense. This is a model in the CMM sense.
CMM sense,
This is about how mature, how repeatable, how well documented are your business processes? So just as CMM is about making sure that software organizations have well-defined ways of writing software, which then helps you to ensure that the quality of the software is good. So BPMM is about making sure that your business has well-defined ways, well-defined procedures for doing all the things that it does. It could be a procedure for hiring a new employee. It could be a procedure for billing a client. Your business typically has hundreds probably of these processes, often carried around in the heads of the people who execute the business. BPMM, if we're to have a hope of automating businesses more, we have to make sure that the business understands what it does. As we as software engineers all know that the number one cause of software disasters is you go to the business people, they tell you what they think they want, you implement it, you go back to them and said, here's what you said you wanted, and they say, well, that's not what we wanted. Because either they didn't understand what they did, or somewhere in the communication between them and you, something got lost. So having good documentation of what the business actually does is important before you can provide an implementation software that does that. And in turn, BPMM will help business analysts going into organizations who want to document what the organization does, will help them to essentially make a judgment as to, whether the organization even knows. If there's one person buried somewhere deep in the bowels of the organization who's the only person who knows what you do when this set of events happens, and it's never been written down, the chances of an analyst or a designer going in to implement that process, finding out what happens when this particular exception occurs, they're essentially zero. BPMM, I think, again, as an analog for CMM, but for business processes, could be quite important.
So why don't we briefly look at how the OMG actually does the standardization process? I've once heard this statement that probably it's not really true, but I thought it's really funny, which was an OMG standard is a political statement masking as a software standard.
Well,
so how does it work?
How does it work? First of all, there's always politics. Even when you're building an application inside a single company, there's always politics. So people say, and criticize us for politics being involved. And I challenge anybody who's been involved in any large project to show me a project that's free of politics. So creating OMG standards is about brokering agreement. It's about making sure that all the people who have a stake in the game, who are going to be implementing tools that implement these specifications, are happy enough. And unfortunately, there is always going to be a degree of compromise, as there is in everything in real life. So what OMG does, and I guess this is reduced to its fundamentals, what I do, what my job is to broker agreement between the stakeholders and help them write the common specification that meets enough of all their requirements that is going to be useful to them. And it is a social process. So the way the OMG process works is we start out by building a small community inside OMG of people who are interested in a particular area. It might be only 3 or 4 people. And they write a call to arms to the industry, a thing called a request for information, which is sent out as widely as we can. It essentially says, OMG thinks that there's a need for a common standard in this area. Please comment. Sent out to anybody, OMG member or not. And we then work through the comments, and the RFI has 2 purposes: 1, to gather information, and 2, to gather more recruits. So hopefully we get to the situation where we've got a nucleus of domain experts working inside a group at OMG. And I should emphasize that although we've been talking about what OMG terms platform standards, which are usable across the entire software industry, we also have a large group of domain standards, which are standards that are used only in a single domain. Finance, for instance, is a good example. We've just been working on payment interoperability standards that are very interesting to people in finance, banks, credit card companies, and not going to be have much impact at all outside that. But inside that industry, very useful.
Healthcare is another one.
Healthcare is another good
about.
example. Yes, you've done your homework. We've got many of these vertical domains, and the process works, roughly speaking, in the same way, both inside and outside these vertical domains. So we build the group of people who have a strong interest in this area, and they write essentially a requirements document. We call it a request for proposals. And even though it's typically only 30 or 40 pages long, that can take quite a long time, because part of it is building a shared agreement over exactly what the requirements are. So we come back to this issue we touched on earlier about arguments over what the words mean. We try to get all the arguments over what the words mean out of the way at that stage. If you've left it until after requirements gathering, it's too late. So it can be quite a protracted process, but we build this RFP. And the RFP is then issued. Now, OMG is a large organization with hundreds of members. We're international, but we're not a government organization.
Financed by membership.
We're financed by members. Yep. We're a club, essentially. We're an industry club. Financed by people who believe that standards are a good thing for the kinds of reasons I mentioned earlier. The UML standard, it builds markets, it fosters innovation. So, but the point I'm getting to here is we have no special exemption under antitrust laws. There are organizations that do, but we do not. So what we can't do as OMG is go out, once we've got the requirements document, and say, right, company A, company B, company C, you've got the best technology in this area. We want you to go out and write an OMG specification.
Okay.
Because if we did, we'd be building an anti-competitive cartel. And company D, who we hadn't invited, could quite legitimately come back and sue us. Both in Europe and in the US and in several other jurisdictions as well. And it's happened. It hasn't happened to us, but it has happened to other organizations. So we're very careful at this point. We issue the RFP, and then as far as OMG, in the narrowest sense of the word, the organization OMG is concerned, we just sit and wait at that point. Now, what's actually happening is large numbers of OMG members are organizing into groups. Sometimes they submit singly, but more often they self-organize into groups. I don't have any say over that. I don't want to. It's not, it's outside for these antitrust reasons. And they create proposals against this RFP and submit them for evaluation back to OMG. And that proposal writing and submission back happens outside our process. So after a few months, we typically are looking at one or more proposals from. It's always several organizations. It's very, very rare that you just get a single company submitting a single proposal. And the group of experts inside OMG, which we call a task force, evaluates these proposals. The task force will certainly include end users. The submitters often have a couple of end users, but it's fair to say that they're often outnumbered by the tool vendors. But this is an important balance. When you're creating specifications, you must listen to both the people who will create implementations and the people who will use them. If you only listen to one of those two groups, what you produce is not going to be used by the other group. So we have an evaluation, and then we go around this loop typically once or maybe twice more. The submitters revise their proposal in the light of the evaluation, and then resubmit, and it's then reevaluated. And when we get to the stage where both the evaluators and the submitters are happy, which can take a couple of iterations, it then goes through, it's then voted on by the task force and recommended to the rest of OMG. Now, at this point, a thing called the architecture board has its say. OMG has a fairly powerful and certainly very highly skilled group of individuals called the architecture board. They're elected by the rest of OMG by an open democratic process. I'm very proud of the fact that everything in OMG is done by an open and fully documented vote. It may be a bit political at times, but it's extremely democratic. And the architecture board's job is to make sure that the work that's been done by this one task force, focusing on one area of the whole technology spectrum, is nevertheless compatible with OMG's other work. So that, for instance, an early job the architecture board did was to ensure that UML and MOF were compatible. And they did a good job there. So the architecture board ensures that the proposal is compatible with other proposals in other technologies, related technologies OMG is working on. And then the architecture board, once they've endorsed it, recommends it to the whole of OMG. And at this point, typically, the hard work is all over. And we have a couple more votes. And
public reviews, I guess.
And public reviews. But usually by the time the task force has made a recommendation and the architecture board has reviewed it and is happy with it, typically by that stage, the thing has really been through the mill, has been really thoroughly examined, and it is actually unheard of. It's never happened for a specification to be then defeated after that, although it does still get widely reviewed. And one specification was withdrawn rather than defeated because it was seen that it wasn't going to get widespread public support. But yeah, it's then published by OMG. First of all, as a so-called beta specification, which is really intended for the tool vendors to start implementing and hopefully feeding back any problems they find. And then after a certain amount of time, as what you might call a public beta, we then go to a full formal specification. And that's the stage where we hope that end users will also start working with it.
You don't publish a compatibility test suite or something?
So interoperability testing and conformance testing is an interesting issue.
Because I mean, you remember in the beginning of MDA, basically every code generator called itself. I'm not saying you called them, but everybody basically called themselves an MDA tool because that was the buzzword of the day. And of course,
well, that's success. It's when a lot of people want to be part of your gang because it seems to be cool to be part of your gang. I guess that's success.
Not a bad sign.
But coming back to the serious point. Interoperability testing, compliance testing against the specifications is very important, and it's something that I personally would like to see us do more of. The problem is it's also ferociously expensive. Building a test suite, a comprehensive test suite to test against the specification is going to cost you, millions of dollars potentially.
Another approach would be to publish a reference implementation like the Java guys do. I think that's quite useful because you prove that it works.
Yeah, reference implementations, I have a slightly contrarian view on reference implementations. Let me give you let me just talk around that. The problem with the reference implementation is that there's a risk it will become the only implementation. You publish a reference implementation, which of course is going to be optimized for just one set of circumstances. Don't forget that in OMG, we're talking about interface standards. It's entirely down to the vendors how they implement things that are behind the interfaces. And to look at middleware, for instance, you could implement middleware that was extremely robust, or you could implement middleware that was extremely fast, or you could implement middleware that was extremely small, or middleware that was extremely scalable.
All the non-functional stuff, basically.
All the non-functional stuff. And you're going to be making trade-offs behind the interfaces for different areas of performance. And so no one implementation is going to meet all those different sets of requirements. If we had published a reference implementation of Corba, the risk is that it would become the only implementation, and it would have a certain set of trade-offs. It would be optimized for being, small or fast or whatever. And any bugs that it had would become the standard, become the reference bugs. And unless your behavior of your implementation was exactly the same as the reference implementation's behavior, people would point the finger at you and say, it's not like the reference implementation, you must be wrong. And you can argue till you're blue in the face. No, look at the standard. The standard here says, this behavior, that doesn't cut it with the customers. I mean, I've seen this years ago outside OMG. I worked on PostScript implementation. It was slightly frustrating business. Adobe had published the specification of what PostScript should do, but unless your implementation did exactly what the Adobe implementation did, including all the bugs where you could point to the places where the Adobe implementation did this and the Adobe specification said something different. If you'd implemented the specification, you were wrong because you didn't do what the Adobe implementation did. And it was very hard. I'm not criticizing Adobe. They're a valued member of OMG. But it was very hard to compete against Adobe because you had to basically do in all circumstances exactly what the Adobe implementation did. And there's a risk that just as the Adobe implementation is the reference implementation of PostScript, and there were very few others, so a reference implementation of Corba would have become the only implementation. Now, that's not an excuse for the lack of compatibility and compliance testing. I would like to see more. We did have compliance testing for Corba. I would like to see more compliance testing for other OMG specifications. The only defense I offer for there not being more is that it is very expensive. We're not a wealthy organization. We are funded by our members. Our membership contributions are relatively inexpensive, and we don't have the money.
Okay.
What it's going to take, frankly, is for a very large customer, maybe somebody like a big oil company, but I think probably a government, to either insist that there be a compliance test and fund it, and then insist that people who sell the products comply with it.
Yeah. To this,
to this
customer. Yeah.
I think that's frankly what it's going to take to get more compliance testing. It's the one. If you gave me 3 wishes as technical director of OMG today, wish number 1 would definitely be, if I could wave a magic wand and make compliance tests, not reference implementations, but compliance tests exist, that would be my number 1 wish.
Yeah. So, do you want to give our listeners an overview between maybe the roles other organizations like OMG, W3C, OASIS, do they cooperate? What's the story there?
Yeah, well, organizations like OASIS, W3C, OMG, we all operate in very similar ways.
Yeah,
all of those 3, we're essentially membership organizations, companies with a shared interest, cooperating in a public process to build non-mandatory standards. And by non-mandatory, I mean that nobody forces you to implement HTML or an OASIS recommendation or one of our standards. We're not, as I say, we're not government de jure bodies.
Yeah.
We focus on different areas of the overall spectrum of standardization, and organizations with different sets of skills and members of different organizations, often with a lot of overlap, of course. A lot of W3C members are also OMG members and also OASIS members. Yeah. Typically, W3C works on web-related stuff, including, of course, stuff related to Web 2.0, RDF, and so on, knowledge classification. OMG is typically working. OMG really, I think, has most of the interesting modeling work going on today, modeling languages, and also a lot of middleware work. Not only Corba, but I should also mention a middleware specification called DDS. Data Distribution Service, which is used extensively in real-time middleware, particularly in ships, naval ships. Yeah. So that's where OMG's areas of expertise are: middleware interoperability modeling. And OASIS started out, of course, focusing on document standards built in XML, and is now doing a lot of XML-based work on representing knowledge in different vertical domains, in different vertical industries. We don't have a formal cooperation or relationship. We do have liaisons with these other organizations, but informally, there's quite a lot of discussion goes on.
Through the members, I guess, because many are...
Certainly through the members. The members make sure that there isn't duplication. It's in nobody's interest for these organizations to tread on each other's toes or try to steal each other's turf.
Yeah.
And also, we do have informal contacts between the staff of the organizations, making sure that we don't duplicate effort between them. So you can think of them as sort of interlocking pieces of the overall public open standards jigsaw.
Yeah.
And something that a value we all share in common is open standards.
Yeah, right.
Open in the sense that anybody can download them, anybody can use them. Subject to the fact that we can't guarantee, and this perhaps again is just worth touching on, we can't guarantee that if you implement an OMG standard, you won't be infringing somebody's patent somewhere.
Okay.
We do our best to find out if there are any patents, software patents, that you would have to license in order to implement an OMG specification. And if we find them, we do document that fact. But we can't guarantee that there isn't somebody, in the vast trackless steppe of Russia, is going to pop up tomorrow waving a master patent on something that we didn't know about. And that also is true, incidentally, of W3C and OASIS as well.
Yeah.
So, but openness, in the case of all 3 organizations, openness and sharing information is the name of the game. And there are analogies with the open source software movement.
Yeah, sure. Yeah.
It's again, we all believe that it benefits everybody, and we all benefit from the work that is done creating these open specifications and open software.
To wrap this up slowly but surely, you mentioned before the BPMN stuff. So this hints at the fact that you're also, as OMG, working in the SOA space.
Yes.
Is there more stuff in the SOA environment or area that OMG is involved in?
Well, as I say, sort of wrapping this all up, drawing a line under it, one of the things that I feel quite strongly at the moment is that there is a synergy and a convergence between these three areas of technology that some people might see as separate: service-oriented architecture, business process modeling and BPM technology in general, and MDA. We feel quite strongly in OMG that SOA is very useful. We've been working in SOA for years. It's a useful way of structuring your software to make it flexible. It's a useful way of structuring your business to make it flexible. And as an aside, I'd just like to mention there is a separate organization affiliated with OMG called the SOA Consortium. And the SOA Consortium's mission is to promote and enable business agility via service-oriented architecture to allow businesses to compete, innovate, and thrive. I'm reading from their mission statement there. One of the things the SOA Consortium is trying to get across is that SOA is not just a way of building software.
Yeah.
It can also be a way of structuring all of your business activities to make them more flexible. SOA Consortium is proving to be quite successful. Gartner is working with us on publicizing and working on the SOA Consortium, and SOA Consortium has had quite a lot of exposure through Gartner conferences. They're very interested in it. But anyway, to return to the major thrust, SOA, BPM, and model-driven approaches. SOA can provide a framework for building a flexible organization. BPM can provide the way of documenting what the organization can do. MDA is the vital bridge between the two. If we're going to build flexible organizations, we need to be able to reconfigure our business processes quickly, to be able to say, we're an insurance company, currently we sell this service, but we want to be able to sell that service. We'll need to use all of our existing underwriting and billing and so on services, but put them together in a slightly different way. Being able to document the new process using business modeling languages, and then automatically produce the glue code that choreographs services to deliver the new service quickly using model-driven techniques. I think that's going to be a very powerful sweet spot. Yes, and that actually is going to be the subject of my talk this afternoon here at the conference.
Okay, very good. So to wrap this up, you probably don't know, but Andrew and I have something in common, and that's we're both glider pilots. And so last weekend was actually quite nice here in Germany. We had strong winds, so we could do quite some ridge soaring, like with 180 kilometers per hour running along the ridge and steep turns and stuff. Very funny. So when was your last flight?
Yes, I've been flying gliders for 15 years or something like that now. But like you, I was flying last weekend. I live in Cambridge in the UK, which is flat land. It's in the middle of cornfields, and it's winter at the moment. So, typically in the summer in those flatlands, you get good thermals, as we call them, columns of warm rising air that gliders can fly in. No thermals in the winter. So, to avoid standing around in a flat, muddy field in the middle of Cambridge, I jumped in the car and I drove 300 kilometers north to a place called Sutton Bank in Yorkshire, and just like you, that's where you were. That's a place with a ridge, and when the wind blows onto the ridge, then the rising air on the ridge you can use to stay in the air. But there's also a kind of lift you get there called Wave, and Wave is magical. I know, Marcus, you've flown in Wave a lot.
Yeah, well, I've once been in 7,000 meters over Switzerland. So.
Yes, yeah, no, it is. It's like a magic carpet ride, because what happens is, as you know, the wind blows over mountains, and it sets up a standing wave in the air that actually goes much higher than the mountains. So there's a fairly low range of hills up the backbone of England called the Pennines. They're only about 300-400 meters, 400-500 meters high. But on Saturday the conditions were just right. The wind was blowing over the Pennines. It was setting up the standing wave, and we were flying to 2,000-3,000 meters in the wave with a beautiful view of the north of England. You could see both coasts.
Wow.
And on other days, flying in America, in the Rockies, I'm sure it's the same with you. I've been to can't convert to meters, but 22,000 feet, what would that be? That would be
Yeah, it's
6.5,
roughly 6,
7,000 meters, yes. On oxygen, looking out of the view, looking down on the airliners.
Yeah.
It's a lot of people think that gliding is just, you go up and you come straight down, but they might be surprised to know that the world altitude record in gliding is 49,000 feet.
Yeah. That's 15 kilometers,
15
roughly.
kilometers above the surface. And people, even in Britain, which is a relatively small island, people have flown 1,000 kilometers in a glider in a single day.
Yeah.
It's great fun. So to all you engineers out there, let me recommend the sport of gliding to you, because as engineers, there's a British expression. I don't know if I'll be able to translate it. Definition of an engineer. An engineer is somebody who can do for 10 bob what any damn fool can do for £1. So an engineer is somebody who can do for 50 euro cents what any damn fool can do for €1.
Yeah.
Engineers are fond of optimization and getting something for nothing. Well, gliding is getting something for nothing. You pay no money. You use the power of the sun to keep you in the air and fly long distances.
Yeah.
Lots of glider pilots are engineers.
And it's fairly cheap, actually. I mean, it's not more expensive than playing tennis or something.
Yeah.
So if you don't buy your own glider, then you with a club, it's actually fairly cheap too.
If you've never tried gliding, it's definitely one of those things that you owe yourself, is to give it a go.
Yeah, absolutely.
And see if it's for you. In Germany, you can fly solo as a glider pilot at 16.
14.
14.
You can fly solo. You can get the license with 16, but we can fly solo with 14.
In Britain, you can fly solo at 16, which is younger than you can drive.
Right. Yeah.
So we've got kids flying gliders around our airfield in Cambridge who haven't got their driving licenses yet, but they're solo glider pilots already. It's not difficult to learn, and it's a lot of fun.
It's probably the best thing you can do with your spare time.
Absolutely.
Although it is addictive, so you have to be careful.
Oh yes, but also I'm sure it's the same with you. Like any addicts, we're also pushers. We're always trying to get new people hooked.
Sure, absolutely.
Yes.
Okay, Andrew, thank you very much for being on the show.
Thanks, Marcus.
Thanks for listening to Software Engineering Radio. If you want more information about the podcast and all the other episodes, visit our website at se-radio.net. If you want to support us, you can donate to the SE Radio team via the website, or you can advertise for SE Radio, for example, by clicking on the Dig, Reddit, Delicious and Slashdot buttons. To contact the team, please send email to team@seradio.net, or if it's specific to an episode, please use the comments facility on the website so other people can read and react to your comments. This episode of Software Engineering Radio, as well as all other episodes, are licensed under a Creative Commons license. Please see the website for details. Thanks to Charlie Crow and the PodSafe Music Network for the music used in this show. The song is called Vegas Hard Rock Shuffle.